Hi, everybody. Thank you for joining me. This is week 6 of our new content. This is your final lesson for the distant learning term 3. And the focus of this lesson is on piecewise functions and transformations. And you'll be looking at the transformations on absolute value and quadratic functions. I want to remind you that this assignment is due no later than June 17th. So this assignment is on Dextot Toys, and it is titled Piecewise and Function Transformations Woolly. And so when you look at the actual deck board, you're going to start in the bottom of the board and enter right here. You'll have an enter task, parabola vocabulary, and then you're going to go right into a Desmos activity where you are going to explore piecewise functions. So the question is, what is a piecewise function? Well, a piecewise function, by definition, consists of a function with at least two equations or pieces, each which applies to a different part of the domain. And remember, the domain are the input values. So if you look at this particular example, there are 3 different pieces or equations given over different parts of the domain. It's a quadratic function when x is less than 2. It is actually a point when x equals 2, and it is a piece of a linear function when x is greater than 2 and less than or equal to 6. So you are going to explore piecewise functions through a Desmos activity, and what I'd like to do is just go through that activity with you. So the first slide says, what is a piecewise function? Click the buttons and try to make sense of the concept. So the function g of x is a piecewise function. Click the buttons to see the pieces of g of x. Take note of the domain restrictions for each piece. So when I click the first button, it's going to graph g of x equals -3, which is right here, and the domain is, or when this function starts, when x is less than or equal to -2. And one thing that I really like about Desmos is as you click the various pieces, it graphs it in different colors. So it's a great visual approach to looking at piecewise functions here. So I'm going to graph the second piece, which is x minus 1, and that function exists between the values of -2 and 3. So x is greater than -2 and less than 3. And then the last piece of the function would be graphed in green. And when x is greater than or equal to 3, your function is -2x plus 8. So then you're going to go on to the next slide, and you would record your big ideas, or what were your observations from this activity. And then the next few slides are going to ask you to take a look at the statements that are false about the function, and then also a statement about the domain. And you'll be looking at each piece of the function. What I want to do is jump ahead and just take a look at the last slide with you. So the last slide is a challenge, and it says a piecewise function, h of x is graphed. Write 3 equations that represent the 3 pieces. So the directions say write an equation for each piece of the piecewise function that is shown. Change each number symbol to the correct value. Complete the equation of the piece, followed by its corresponding domain restriction in brackets by changing each 3 to the correct value. All right. And so the first piece in orange I did for you. And so let me just take it out. I forgot I had done this already. I was exploring the activities myself. So it's going to look like this, and it's going to say h of x equals some number over the domain x is less than or equal to 3. So I already actually had the answer up. So you can see h of x is equal to the value of 3 for the orange piece. So you would input the value of 3 next to that number or pound symbol, and the domain starts at -4 and goes to the left, so x is less than or equal to -4. And then you would go through and you would do the purple piece that starts here at -4 and goes to 1, and you would write the equation for that line. And then finally, the red piece. Once you're done, you'll submit that activity, and you will go on to the next piece of the board, which is to watch an ed puzzle on absolute value transformations. And then all these activities have to do with absolute value transformations, which are similar. Once you look at transformations, the parameters A, H, and K, which are the parameters in a function written in vertex form, in this case, all are the same. So what you learn about absolute values will functions, those transformations will transfer over to a quadratic function. And then you do some more activities along here, and you'll watch an ed puzzle piecewise value functions, and that will be on evaluating them. Then you'll go through some more activities, and finally you're going to make a choice of what you want to do at the end. You can do an edulastic assignment. You can do a Desmos art assignment. And on that Desmos art assignment, you would actually have to be creating a piece of Desmos art, and it's string art, and the picture should load in a second. And here it is. And then the last assignment would be to make your own grade video. I know there was about a half a dozen of you that made the videos last time. Thank you so much. Those were beautifully done. So your choice comes at the end of this board on how you want your sort of exit activity, what you want to do, whether it's an edulastic assignment, creating that nice string art using Desmos, or making a flip grid to talk about and show what you learned. So the second part of the board, or the majority of the rest of the board, as I said, concentrates on transformations. So I'd like to go through that with you right now. After you complete your piecewise Desmos activity and those related activities, the next thing you're going to do is look at the transformations of an absolute value function. In an absolute value function, it's a very famous piecewise function. It contains two pieces or two linear parts. X is equal to y when your input or your x domain values are greater than or equal to 0, and then it is equal to the absolute value of the opposite of x when x is less than or equal to 0. So this is what the parent function looks like. It is symmetric about the origin. The vertex, which is your corner point, is at the origin, 0, 0. And your axis of symmetry, that equation would be the x equals 0, which is the y-axis. So the next thing you would do is you would concentrate on the parent function. And what are the big ideas from the parent function? Well, it's a V-shaped curve. As I said, it's symmetric about the y-axis, and the vertex is the minimum point at the origin, 0, 0. So then you're going to compare it, the different types of transformations that you can do on the coordinate plane to the parent function. Transformations would be to reflect it, have it the absolute value function pointing up or down. You could change the steepness or the width of it, making it more or less steep. You could shift it horizontally, left or right, or shift it vertically. So the first transformations that you'll look at is the translation. And remember, translation is a slide. So that shifts the function either horizontally or vertically, but it does not change the overall orientation or the shape of the function. So remember, orientation would be the direction that it's opening up or opening down. And then the next thing that you would look at is actually changing the overall the orientation, and then how wide or how steep that function is.